ideal diodes for our situation, we need to find which of these is true for the circuit shown. So with our circuit, there's a few things to note. First, we have some voltage right here, we have a resistor here, a diode right here, resistor, and a voltage. Now, without this diode, it would look something like a voltage division. So that's just good to keep in mind. When we look at this, we are first going to look at the different types that it could be. And it's going to look like part B, but also a little bit of part D. We can see that we have a battery right here with our diode. And since we have a battery with our diode, our graph is going to look like this. However, we can see that the diode is facing upwards this way. And how I like to look at it is that the triangle is pointing in the direction that the graph is going. So graph is going up like this, and that's just the voltage output over the voltage input, which is kind of like the gain. So when we draw this out for our graph, it's going to look something like this, and I'll just draw it right here. So we have our graph like this. And for our graph, we have some cap, like this, but it's going to be on the lower end. The reason why it's on the lower end is because the different direction of our diode. So this right here is going to look like this, and then it's going to go up through the midpoint and like this. And this point right here is going to be a negative V1, and then minus our D1 as well, right? That's like 5.7 here when we had 5 volts, and our diode is 0.7. So you have minus V1 minus D1. And this is just going to keep going on for infinity. Well, not for infinity, but relatively. So the first one says the gain is equal to 0 when our V is less than our negative V1. Well, when our V, this is voltage output over the voltage, we'll start T. When our V is less than the negative V1, we are going to be in this area over here. And in this area, we can see that it flattens out. And so it's going to be 0. So this is true. Next, let's look at the maximum output voltage is not limited. Well, we just said this is going to keep going. So the maximum output voltage right here is going to keep going. Therefore, it's not limited. Next, we have the minimum output voltage is negative V1. Well, the minimum output voltage is going to be right here, right? This is where it goes flat. So our minimum output is, yes, going to be this negative V1. The gain is equal to our RL divided by our R plus RL when V is greater than V negative 1, or negative V1. And let's look at this. Well, if we get rid of this diode right here, we assume that it's off. This whole branch is going to disappear from our circuit. And then we just have voltage division. And with voltage division, we know that we have our voltage output equal to voltage input, but that's not what we're concerned about. What we're concerned about is the resistance that this is over, so RL. If we were doing current division, it'd be like this R over this RL. It's kind of the opposite. But we have this RL over RL plus our other resistor, which is R. And that is what we have right here. And we know that just looking at this, what we have right here, it's a 1-to-1 ratio, right? 1 over 1, rise over run is 1-to-1. And so this is equal to our V output over V input. But this could only happen right here. It only starts being 1 over 1, V out over V input, when our V, any voltage, is greater than this negative V1. And so this is also true. And so the answer for this problem is going to be all of these.